Alright, hello everyone. Today was day 20 of Admin of Code, and today was a bit of a tedious puzzle in my opinion. And in particular, part 2 was quite hard, but let's check it out. Today's problem was all about pulses and having modules that send pulses to each other. And a pulse can either be high or low, and we're supposed to track the pulses being sent. So there are different modules which behave different when receiving and sending pulses. So first we got a flip-flop module, which has a state, which is either on or off, and then depending on that, it sends out pulses. There's a conjunction module, which remembers for each of the modules sending to it whether the last pulse received was high or low, and depending on that, it sends out high or low pulses. And there is a broadcast module, which just sends the same pulse it receives to all the modules receiving from it. So our input will look something like this. That will always tell us the name of a particular module, and then it tells all the module names that receive from the first module. And then also the signs tell us whether the module is a flip-flop module or a conjunction module. And yes, so we also have a single button module. The button, if we press it, sends a low pulse signal to the broadcaster, and then the broadcaster will send that to multiple other modules. And what we're supposed to do is, whenever we press the button, that will accord a number of pulses to happen. And it turns out the button has been pressed 1,000 times, and we're supposed to calculate for the first part how many pulses actually have been sent around. All right, so let's have a look at the code. So we need to represent all these pulse modules and pulses somehow. So for the pulse, I chose a data class. So a pulse will have 3 important values, so whether the pulse is high or not. And then we'll also keep track of the name of the sender and the name of the receiver. And then we have different pulse modules. For that, we have a general pulse module class, which first will keep track of all the high pulses sent and low pulses sent, which will help us to find a solution in the end. And then when we initialize a module, that we save the name, and then we also initialize an empty list as the receivers and an empty list as the senders. Then we'll also have methods to add receivers and senders, which just append them to the corresponding lists. And then each pulse module will also have a function that processes a pulse. And for processing a pulse, we'll just return a list of pulses to be added to the queue. And that will be implemented by all these subclasses. And finally, we have a method send pulse, which is just a convenience function for pulse, whether it's high or low. We first update the counts depending on whether the pulse is high or low. And then for each receiver, we create this pulse that keeps track of whether it's high or low, the name of the sender and the name of the receiver. And return the list of all these pulses to be appended or extending the queue. Okay, so then the subclass of this is first a flip-flop module. So flip-flop module has a state which starts as false, and then in order to process a pulse, if the pulse is high, we don't do anything, and we also don't send out any pulses, so we return an empty list. Otherwise, the state of the flip-flop module flips, and then it sends out a pulse depending on the state, that if the state is on, it is high, and if the state is off, it's low. Next module is a conjunction module. So the conjunction module will have to keep track of all the incoming pulses. So we have a dictionary which tells us for each sender whether the last incoming pulse was high or not. And then also when we add the sender, we also update this dictionary. And for each sender, at first, this property, whether the last incoming pulse was high or not, is set to false. And then when we process a pulse with the conjunction module, what we do is first we update this dictionary depending on the pulse. And then if all the last incoming pulses were high, we actually return a low pulse, and otherwise return a high pulse. Okay, that's the 2 main modules to process pulses. We also got the broadcaster module, which just whenever it processes a pulse, it sends it to all it sends the same pulse, high or low, to all the modules receiving from it. And then we also got the button module. And the button module we just use to send an initial low pulse to the broadcaster module, and it's not supposed to process pulses actually. All right, with all those modules defined, we want to parse the input. So of course we need to read the file as usual, and then in order to parse the input, we go through all the lines and then parse the module in this line. So a line might look something like this or this. So the first part will tell us the name of the module and the kind of the module. So depending on what this name string starts with, the module will be either flip-flop module, a conjunction module, or the broadcaster module. And we'll also keep track of the name. And then we initialize this particular module, and then we go through all the receiver names and add the receivers to this current module. After doing that and going through all the input lines, we also want to add the correct senders to each module. So we do that by going through all pulse modules we found. And then for each pulse model, we go through all the receiver. And if the receiver, and then we get the receiver module. And for some receiver modules, for example, for this output module, we might not actually have it in this dictionary. So if it's none, we ignore it. If it's not none, for this receiver module, actually we add the sender. And we add the current module as a sender. Okay, so then finally we want to add this button module. So we create it, and then the only receiver of the button module will be the broadcaster. And yes, that should give us all the modules and all the connections among them. Okay, then in order to solve the problem, we just parse the line, we get all the pulse modules, and then we press the button 1,000 times. And for each button press, we process the button press and all the pulses being sent. And then in the end, the solution will just be the number of high pulses sent times the number of low pulses sent. In order to process a button press, what we do is first we press the button. So we have the button and send the low pulse, and we add this one pulse to the pulse queue. So it will be a list and containing such a single pulse sent by the button module. And then we iterate while we have pulses in our pulse queue. We get the first pulse, and then we get the receiver module. If the receiver module is not in our dictionary, for example, the output module, we continue. Otherwise, the receiver module will process the pulse. That will give us a list of new pulses, and we add them to the queue. Okay, that's it for part 1. We should, of course, try then the test input, and that looks good. So I can also run it on the real input, and it also turns out it gives us the right solution. Okay, part 2 seems fairly easy at first. So there's a particular receiver with the name of Rx, and we're just supposed to keep pressing the button until this receiver Rx receives a low pulse, in which case we report the number of times we press the button, and that will be our solution. So first we can try to solve this like part 1 with some kind of brute force solution. So just keep pressing the button and processing the pulses as before. The only new thing is these 2 lines where we check if the receiver is actually Rx and if the pulse is low, then we return the number of times we've pressed the button. So if we run that on our input, for example, for 10,000 iterations, it turns out it does not find a solution within 10,000 iterations. And even if we run it for more iterations, if we press the button more times, it does not seem to give us a solution. So we need to be a bit smarter. So first we can check our input, and we notice that Rx only actually receives pulses from one particular module, which is called Rg, and it's a conjunction module. So Rg will need a positive high inputs from all its modules in order to send a low pulse to Rx. So we can first inspect that when Rg actually gets sent high pulses from the module sending to it. So we define this function that finds the incoming high pulses for a particular module with a particular module name. So what we do is we just have this dictionary, which for each sender to the module of interest tells us each iteration during which the module of interest received a high pulse from the sender. Yes, and we fill this dictionary up, and then we can inspect it and see if there's anything that looks promising. So we have this loop, and in each iteration, first we check if the pulse queue is currently empty. Then what we'll do is we press the button, so the button module will send its one pulse, and that will be the new pulse queue. We also add 1 to the number of times that the button was pressed. And we also check if we press the button often enough, we return this dictionary. Otherwise, we just process a pulse as usual. So we get the first pulse from the queue, we get the receiver module. If the receiver module is something like the output module, we continue. We don't consider it. Otherwise, if the receiver module is in our dictionary of pulse modules, the receiver module will process the pulse, giving us a new list of pulses, which we add to the pulse queue. But then we also check for each sender that sends pulses to our model of interest, or we will check if the last pulse the sender sent to the model of interest was high. If this is the case, we check whether we already reported this particular iteration. Otherwise, we'll append it to this list, which gives us all the iteration in which the sender sends a high pulse to the model of interest. Okay, so we can run this function on our input. And if we do that, the resulting dictionary will be something like this. So first we note, or we see that RG actually very rarely receives high pulses. So particularly out of the first 10,000 iterations, it only received a high pulse twice from sender named KD. And second, we can also note that the second time it received a high pulse was actually twice the iteration from the first time. And the same for all the other senders. So we can hope is that we found a pattern there, so that KD will only send high pulses to RG during epochs that are multiple of this value, and maybe then the same for all the other senders. And if this was the case, then the first time we have a chance of RG sending a low pulse to Rx is during the lowest common multiple of all these values. Now, it's definitely not guaranteed that during this iteration it will actually happen that RG sends a low pulse to Rx, but it might. So we can check if that might be the correct solution, and we can try to find it. So in order to find this value, what we'll do is that we'll use this function that we defined before. So as the whole solution for the problem, we first pass the input to get these pulse modules, and then as before, we find this incoming highs for this RG module. And then we find the periods of each sender by finding the minimum time. And then we hope that our solution is the lowest common multiple of all these periods. And if we run this, this actually gives us a very high value, which for my input at least turns out it gives us the right solution. So this solution is not particularly satisfying, but at least it does give me at least the correct solution. If I find a better solution, I'll post it in the comments or in the description of the video. And yeah, that's it for day 20. I hope you enjoyed today's puzzle. Best of luck in the future, and I'll see you around.